Hello dear students, welcome to physics online classes of P1. So in the previous video class we have discussed about the chapter mechanical properties of fluids. In particular we have discussed about the Pascal's law and its applications. Now in this video class let us discuss about the one more important point, that is the next part of this syllabus, that is the types of flow of fluids. There are two types of flow of fluids. One is streamline flow and another one is turbulent flow. These are the two types of flow of fluids. Since flowing liquids are considered to be incompressible, that means what? The density of the flowing liquids is constant. The flow of liquids may be smooth or irregular. The smooth flow of liquids is called as what? The streamline flow, and the irregular flow of liquids is called as the turbulent flow. If there is no force of friction between the different layers of the flowing liquids, then the liquid is treated as what? Non-viscous. So when you say that the liquid is non-viscous, there is no force of friction between the different layers of flowing liquids, then the liquid is called as what? The non-viscous. Now let us discuss here in detail about the streamline flow and the turbulent flow. So now we have the two types of flow of liquids here. One is the streamline flow and another one is turbulent flow. Now let us discuss here in detail about the streamline flow and the turbulent flow and their characteristics and their differences. So what is meant by a streamline flow? When the flow of fluid is such that the velocity of every particle of the fluid at any point is constant, then the flow is called as what? The streamline flow, or it is also called as the steady flow. The velocity of every particle of the fluid at any point is constant, then it is called as what? The streamline flow. So for understanding purpose, now let us consider here the flow of fluid in a tube as shown in the figure here. The path followed by the particles of the fluid is represented by the line ABC. So here the path followed by the particles of the fluid is represented by the line ABC. The line ABC represents what here? The line ABC represents the path followed by the particles of the fluid. Now V1, V2 and V3 be the velocity of the particles, the velocities of the particle at A, B and C respectively. That means what? The velocities of the particle at point A is V1, the velocities of the particle at point B is V2, the velocities of the particles at C is V3, right? If all the succeeding particles of the fluid move along the ABC with velocities V1, V2, V3 at A, B and C respectively, then the flow of fluid is known as what? The streamline flow, or it is also called as what? Steady flow. So the velocity of all the particles which are crossing the point A is having the velocity is V1 only. The velocity of all the particles crossing the point B has velocity V2 only. The velocity of all the particles crossing the point C is the velocity is V3 only. Then the fluid is known as what? The flow of fluid is known as what? The streamline flow, right? So all the particles of the fluid move along the path ABC with velocities V1, V2 and V3 at point A, B and C. Then the flow of fluid is known as what? The steady flow or streamline flow. And one more important point is what is meant by streamline. So what is meant by streamline here? The path followed by the particles of the fluid is called as what? The streamline. So streamline, it is just nothing but what? It is a path followed by the particles. That path is called as what? The streamline. So now we have got here the idea about what is meant by streamline, right? The velocity of all the particles or every particles of the fluid at any point during the motion is constant, then it is called as what? The streamline flow. Now what are the important characteristics of streamline? So first important point here, what a tangent at any point on the streamline gives the direction of the velocity of the fluid particle at that point. So now how to find the direction of velocity of the fluid at any point? That is what here, a tangent at any point on the streamline. So here we have drawn the tangent at point A, right? So at point A, here we have drawn the tangent. So the tangent at point A, that is v1, the velocity of the particle at point A is v1. So that is the tangent we have drawn here. So similarly here, a tangent at any point on the streamline gives the direction of velocity of the fluid particle at that point. So here v1, v2 and v3 represents the direction of velocity of the flow of fluid at that point. So first characteristics of streamline flow is what? A tangent at any point on the streamline gives the direction of velocity of the fluid particles at that point. The next important point is the two streamlines never intersect each other or cross each other. So what does it mean? So if the two streamlines intersect, then what happens? So here what we are saying here, two streamlines never intersect each other or cross each other. If they intersect, then at the point of intersection, the particles of the fluid will have two directions of motions. So at the intersecting point, so if the two streamline intersect here, at the point of intersection we have two directions of motion of the fluid particles. So this is not possible here, hence the two streamlines cannot cross each other or they cannot intersect each other. So this is the second characteristic of what the streamline flow of liquids. And the streamline may be straight line or curved. So here the streamline means what? The streamline means the path followed by the fluid particles under the steady flow is called as streamline, and this streamline may be what? The straight line, or it may be curved line. And the examples for streamline flow of fluid or liquids is the flow of water through a capillary tube, the flow of water steadily in a hose pipe are the examples for the streamline flow. Here the fluid can possess a streamline flow only when its velocity is less than the limiting velocity, that is called as the critical velocity. So as we have seen here, the two important types of flow of fluids, one is the streamline flow and another one is turbulent flow. If the velocity, the fluid can possess a streamline flow only when its velocity is less than the limiting velocity, that is called as critical velocity. If the flow of liquid, that is the velocity of the fluid is increases or more than the critical velocity, then the flow of liquid can be considered as what here? The turbulent flow. So here we are defining what is meant by critical speed or critical velocity. The maximum velocity of the fluid above which a streamline flow becomes turbulent flow, that is called as the critical velocity or critical speed. The maximum speed of fluid above which the streamline flow becomes turbulent flow. So as we have two types of flow of fluids here, one is the streamline flow and another one is turbulent flow. Streamline means the velocity of every particles of the fluid at any point is constant, then it is called as what? The streamline. So if the velocity of the fluid exceeds the critical velocity, then the streamline flow becomes turbulent flow. Now then let us discuss here what is meant by turbulent flow. Now what is meant by a turbulent flow? The turbulent flow is defined as what? It is a type of flow in which the fluid particles move in a zigzag way. The fluid particles crosses the paths of each other, that is called as the turbulent flow. So in rivers and canals where the speed of water is quite high, or the boundary surfaces causes what? The abrupt change in the velocity of the flow, then the flow becomes irregular. Such a flow of liquid is known as what? The turbulent flow. So exact what we can define here, the turbulent flow is the flow of fluid in which the velocity of all the particles crossing a given point is not same. So one particle crosses the point with velocity v1 and another particle crosses the same point with other velocity. So that means what? The flow of fluid in which the velocity of all the particles crossing a given point is not same. Then the motion of the fluid becomes irregular or disordered, is called as what? The turbulent flow. So in turbulent flow, what happens? The velocity of fluid is very high, which is greater than the critical velocity or critical speed, and it does not remain constant. The velocity is different both in magnitude and direction. Hence, the flow of fluid particle, that is, the fluid particles move randomly in all the direction with different speeds. The examples for the turbulent flow of fluid is the flow of water in a river, waterfalls, cyclones, tsunami, etc. Etc. All these are the examples for what? The turbulent flow of fluid. And the flow of fluid through a pipe of different cross section, it is also an example of what? The turbulent flow. Now let us see here the what are the difference between the streamline flow and the turbulent flow. So as till now we have discussed the two types of flow of fluids. One is the streamline flow and another one is the turbulent flow, and what is critical speed. Now let us discuss here the difference between the streamline flow and the turbulent flow. The streamline flow means what? It is an ordered flow of fluid. That means it is a steady flow of fluid. And turbulent flow means what? It is a random flow of fluid. It is a zigzag motion. The path of flow of fluid is same in streamline flow. That means the velocity of every particle crossing a given point is same. And turbulent flow, the path of flow is changing. That means the velocity of the particles crossing a given point is different. Now the one more difference is the velocity of flow of fluid is less than the critical velocity. So the velocity of the particles in case of streamline flow is which is the less than the critical velocity, and in case of turbulent flow the velocity of the fluid is greater than the critical velocity. So you know that when the flow of fluid, the velocity of flow of fluid is greater than the critical speed, then it follows the turbulent flow. And one more important difference is there is no mixing of various layers with one another. So the liquids have various layers, though there is no mixture of layers with one another in case of streamline flow. But in case of turbulent flow, there is always a mixing of various layers with one another takes place. So these are the important difference, or the difference between what the streamline flow and the turbulent flow. Now one more type of flow of fluid is laminar flow. It comes under the streamline flow only. If the liquid flows over a horizontal surface in the form of layers of different velocities. So when a fluid is, or the liquid is flowing on a horizontal surface in the form of different layers with different velocities, then the flow of liquid is called as the laminar flow. And in case of a laminar flow, the particles of one layer do not enter into the another layer. So this is called as what? The laminar flow. And the laminar flow is also what? A streamline flow. Only point is what? Here the different layers of liquid we have with different velocity, and all the particles of that layer moves with the same velocity. That is called as what? The laminar flow, and it is a streamline flow only. The next part of the syllabus is the equation of continuity, or it is also called as what? The conservation of mass. The equation of continuity expresses the law of conservation of mass in fluid dynamics. Now, according to the principle of continuity, if an ideal fluid flows through a tube in a streamline motion, then the product of cross-sectional area of the tube and the velocity of flow is same at every point. So according to the equation of continuity, A into V is equal to constant, or A1 V1 is equal to A2 V2. So what is A here? It is cross-sectional area of the tube, and V is the velocity of flow of fluid. So now let us consider here a liquid or the fluid which is flowing in a tube of cross-sectional area, of different cross-sectional area. Now if you consider here at point A, the cross-sectional area of the tube is A1, and at point at point B, the cross-sectional area of the tube is A2. So here it is a tube of different cross-sectional area, and the velocity of the fluid at point A is V1, and the velocity of the fluid at point B is V2. Now according to the principle of continuity, A1 V1 is equal to A2 V2. Here the liquid enters the tube with velocity V1 and leaves the tube with velocity V2. Since the same volume of liquid crosses the each section of the tube in unit time, the volume of the liquid entering the tube in unit time is equal to the volume of the liquid leaving the tube in unit time. So that is equal to what we are writing here. There is no sink or source. No liquid is leaving or entering in between the points A and B. So that is what the law of conservation of mass. The mass flux at point A is equal to the mass flux at point B, right? So according to the principle of continuity, therefore A1 V1 is equal to A2 V2, or A into V is equal to constant, right? The volume of the liquid entering the tube in unit time is equal to the volume of the liquid leaving the tube in unit time. So A into V is equal to constant. This expression is called as what? The equation of continuity. A1 V1 is equal to A2 V2, or A into V is equal to constant. This expression is called as the equation of continuity for steady flow of an ideal fluid, or for streamline motion. So from this equation you can write as V is inversely proportional to the cross-sectional area of the tube. That means what? The speed of the liquid is high where the tube is narrow, and the speed of the liquid is low where the tube is wide, right? According to this equation, what we can conclude here, as the area of the cross section of the tube becomes larger, the fluid speed becomes smaller, and vice versa, right? This is known as the law of conservation of mass, or equation of continuity. A1 V1 is equal to A2 V2, right? As the area of the cross section of the tube becomes larger, that is the speed of the fluid is inversely proportional to cross sectional area of the tube. When the speed of the fluid is more, that means what? The cross sectional area is small. It is inverse proportional, or vice versa, what we can say here. As the area of the cross section of the tube becomes larger, the fluid speed becomes smaller. When the area of cross section of the tube becomes smaller, and the speed becomes large. So in this way we can state here what? The continuity equation. A1 V1 is equal to A2 V2, or V is inversely proportional to A. The speed of the liquid is high where the tube is narrow, and low where the tube is wide. Okay, this is about the equation of continuity. Okay, in the next video class we will discuss about the Bernoulli's theorem. Thank you, students.